For months, astronomers had watched 3I Atlas glide through the darkness, catalogued as nothing more than an interstellar relic. Just dust, ice, and gravity, a frozen visitor from another system. Yet, when the readings began to change, so did the tone of the reports. The comet's light no longer behaved like light. It pulsed every 7 minutes and 12 seconds, steady, deliberate, and unnervingly precise. Before we go further, take a second to subscribe if you haven't yet, and tell me the exact time and city you're listening from right now in the comments. Because this story isn't just being told, it's still unfolding, in real time. When the next pulse reaches Earth, I want to know who among us was awake to catch it. At first, the pattern was dismissed as interference, a quirk of instruments overwhelmed by distance. But when observatories in France, Germany, and Chile cross-checked their logs, the timing aligned perfectly. That was when someone noticed something else, a second signal. Trailing exactly 0.07 AU behind 3I Atlas. It wasn't a fragment, and it wasn't debris. It was colder than the cosmic background itself, a moving void that mirrored the comet's every shift. The silence surrounding it wasn't absence anymore. It was structure. Across the scientific networks, late-night messages turned cautious. Magnetometers, spectrographs, even deep-band receivers all recorded the same heartbeat, a synchronized pulse that made no sense. Each time 3I Atlas brightened, Mars's thin ionosphere answered a few seconds later, as if the planet were listening. Data that should have been noise began forming rhythm, and rhythm began forming intent. From that point, the vocabulary of astronomy began to erode. Words like coincidence and randomness quietly disappeared from the reports. They were replaced by correlation, resonance, and finally, guidance. Because whatever 3I Atlas was doing, it wasn't drifting, it was navigating. What follows isn't theory. It's reconstruction verified data from the observatories that first saw the silence move. Numbers that align too perfectly, temperatures that fall too sharply, magnetic fields that seem to remember their last position. All pointing to one conclusion that no one was ready to write down. 3I Atlas is not alone, and the shadow following it, the one that absorbs instead of shines, may not just be a reflection. It may be part of a design. Now, let's go back to where that realization began, the night the Nancy Observatory first heard the silence pulse like a living thing. The discovery at Nancy Observatory. Night over the Lorraine Plateau is usually silent. The hills reflect nothing but wind, and the faint hum of equipment from the Nancy Radio Observatory. But on June 2nd, 2025, that silence cracked not with sound, but with data. The French team had been recalibrating deep-band receivers aimed near the orbital path of 3I Atlas. Their goal was routine. Measure background plasma noise as the interstellar object moved closer to Mars. What they found instead was repetition. Every 7 minutes and 12 seconds, the same pulse appeared an echo of the primary 3I Atlas signal. Weak, precise, impossible. At first, it looked like interference from a terrestrial relay, but cross-checks with the Nancy decametric array confirmed it. The second source was in motion, not stationary, not Earth-based. It followed the comet's projected path with mathematical obedience. The signal wasn't random static. Its carrier frequency was slightly shifted enough to suggest a Doppler effect, consistent with something trailing behind the main body by roughly 10 million kilometers. The team thought it was debris, maybe a fragment ejected during 3I Atlas's acceleration phase near Jupiter's orbit. Yet, debris drifts. This echo didn't. It matched velocity to the meter per second. The ratio between the two sources held steady across 48 hours of continuous observation. The more they measured, the less it resembled chance. By June 5th, 3 separate observatories had verified the anomaly. Goldstone in California, Effelsberg in Germany, and Nancy in France all reported the same modulation delay. The numbers lined up too perfectly, 7 minutes 12 seconds between peaks. The rhythm was so clean it began to feel biological, like a heartbeat too regular to be natural. One of the technicians joked that it was breathing in sync. No one laughed. The next step was optical confirmation. Using the CNRS 1-meter telescope in Meudon, they captured a sequence of deep field exposures along the projected trajectory. On the third night, a faint dimming appeared, not a flare, but a drop in luminosity trailing 3I Atlas by a constant interval. Software analysis eliminated camera noise and cosmic rays. The dip was real, and it moved. A shadow, following something that shouldn't have a shadow at all. At the same time, an intern processing spectrographic data noticed a peculiarity in the CO2 emission lines. The primary object showed expected sublimation peaks, but a second, weaker echo mirrored those same peaks, offset exactly by the same 7-minute delay. In spectroscopy, symmetry is everything. Random outgassing could never reproduce identical spectral fingerprints. That meant two separate bodies, sharing chemistry and timing. The Nancy team sent their report to the European Space Agency under the heading Secondary CO, 2 resonance, detected in 3 I Atlas wake. Internally, they gave the source a codename, Atlas B. It sounded mundane, almost bureaucratic, but for the scientists staring at the numbers, it felt heavier, like naming a ghost. By June 10th, the debate spread through astrophysics circles. Was Atlas B a fragment, a reflection, or an independent body? Its behavior refused all three categories. A fragment should slow down, a reflection should fade, and an independent body should drift. Yet Atlas B did none of those. It maintained position as though locked by command. Late that night, Dr. Hélène Dubreuil, the lead radio astronomer, rewound the telemetry logs. She isolated the first pulse ever captured, timestamp 2 hours, 13 minutes and 41 seconds UTC, and aligned it with Mars's rotational phase. The pulse arrived exactly when the Martian subsolar point crossed 0 degrees longitude. A cosmic coincidence, perhaps. But her instinct whispered otherwise. She wrote a single note in her lab book. The echo knows where Mars is. From that moment, the word twin began appearing in internal memos. No one dared use it publicly yet. But across observatories in Europe and the United States, researchers quietly updated their observation parameters from tracking a single interstellar comet to following a pair. 3. I Atlas was not alone anymore, and the night skies above Nancy would never sound the same. By mid-June 2025, the pattern was undeniable. Every new dataset arriving from the Nancy Observatory, Goldstone, and the Deep Space Network in Canberra confirmed the same measurement. A constant separation of 0.07 astronomical units, roughly 10.4 million kilometers, the exact distance that had first appeared as a statistical curiosity. Now, it was a law of motion. At first, physicists tried to fit the behavior into existing orbital mechanics. If 3I Atlas had ejected a fragment at the right velocity, perhaps gravity and drag could have stabilized it behind the primary body. But the numbers refused to cooperate. Gravitational coupling alone couldn't produce a tether so rigid. Any fragment, no matter how precisely released, would either spiral outward or collapse back toward the nucleus. Yet the twin, still officially labeled Atlas B, remained perfectly locked in place. When data from the James Webb Space Telescope arrived, the problem deepened. The twin's faint infrared signature moved not independently, but in perfect synchrony with 3I Atlas's microaccelerations. Every time the comet adjusted course, however subtly, the second object compensated within minutes. The phase lag was consistent, measurable, and strangely precise 7 minutes 12 seconds, the same rhythm first observed at Nancy. The separation wasn't just spatial, it was temporal. The twin seemed to exist half a beat behind. At the European Space Operations Centre in Darmstadt, orbital analysts built simulations to test how two masses could maintain such coordination. Classical physics offered no stable solution. To keep a fixed distance without an active feedback system, the twin would need a gravity field finely tuned to counter solar perturbations, something no natural body could achieve. One researcher proposed an electromagnetic tether, a thin plasma conduit linking both objects through charged particles in the solar wind. The idea was dismissed at first. But when magnetometer readings from the Parker Solar Probe showed alternating polarity bands along the comet's route, the theory no longer sounded like science fiction. Meanwhile, astronomers at CNES noticed something subtle in the light curves. The tiny variations in brightness produced by 3I Atlas's rotation were echoed by the twin, delayed again by that constant temporal offset. The same geometry, the same amplitude, as if both shared a single rotational identity. It wasn't a simple follower, it was a reflection, orbiting through a mirror equation. The constancy of 0.07 AU soon became the most debated number in astrophysics. Why 0.07? Why not 0.05 or 0.1? The answer might lie in resonance. When converted to seconds of light travel time, the distance equals 35 light seconds, a value eerily close to the synchronization interval between Mars's atmospheric oscillations and the comet's emission bursts. To some, that was pure coincidence. To others, deliberate engineering. Dr. Dubray from Nancy phrased it more carefully. Either we're witnessing a new kind of orbital resonance, or we're watching guidance. Her team observed something even more disquieting. In the raw radio data, faint subharmonics appeared exactly when the distance between Atlas and its twin fluctuated by fractions of a kilometer, fluctuations that immediately corrected themselves. It was as if the two objects were exchanging corrections, adjusting to maintain their separation, like spacecraft flying in formation. By the end of June, ESA issued a restricted memo warning that the twins' behavior defies inertial modeling and suggests active stabilization. The press never saw it, but among astronomers, the phrase "the lock" became shorthand for a mystery that no one could yet name. Then came the strangest observation of all. Using high-frequency radar, the twin briefly reflected a pulse that returned with inverted phase negative echo. In physics, that can happen only if the surface acts like a phase conjugate mirror, sending back energy as if time itself were reversed. A comet shouldn't do that. Ice and dust can scatter light, not invert it. The only materials known to produce such behavior are engineered metamaterials designed to manipulate electromagnetic waves deliberately. The 0.07 AU lock was no longer just a spatial measurement. It was evidence of control of a system maintaining cohesion across millions of kilometers through mechanisms unknown. As the data spread through observatories worldwide, silence settled again. Every researcher knew what they were looking at, but none wanted to say it out loud. Because if the lock was intentional, then 3I Atlas wasn't just being followed, it was being guided. By early July 2025, the spectrographs began to whisper the same story. The orbital models already suspected that 3I Atlas was not alone in motion, nor in composition. At the Laboratory for Space Instrumentation in Paris-Saclay, scientists ran a comparative analysis between two streams of data, the verified spectra of 3I Atlas and a fainter, the secondary trace that mirrored it from the void 0.07 AU behind. The result was unsettling in its symmetry. Both signatures displayed strong carbon dioxide emission lines near 4.26 microns, the chemical fingerprint of sublimating ice. Yet the secondary trace carried something else. Its intensity curve was smooth, almost engineered, lacking the chaotic flicker typical of natural outgassing. The ratio between its CO2 and dust reflection stayed constant for hours, unaffected by solar flux variations. In nature, comets breathe irregularly. They pulse with sunlight, rotate unpredictably, and vent gas in fits and bursts. But the twin of 3I Atlas seemed to exhale by algorithm. When the James Webb Space Telescope turned its MIRI instrument toward the region, it confirmed what ground telescopes could only hint at. The spectra from both bodies matched in composition silicates, frozen volatiles, trace hydrocarbons, but diverged dramatically in thermal behavior. The leading object burned warmer by nearly 40 Kelvin, consistent with direct solar exposure. The trailing one absorbed more than it radiated, remaining anomalously cold, a near-perfect black body. Dr. Elodie Marchand, a spectroscopist at the CNRS, noted that its emissivity varied inversely with the solar wind flux, as if the twin actively managed its own temperature. She wrote in her report, "It behaves like an adaptive surface, one that knows when to hide." The theory spread quickly. Perhaps the twin wasn't solid at all, but composed of photonic plasma, a thin membrane of charged dust trapped in magnetic confinement. Yet the spectral reflections argued against it. Metallic line residues appeared near zero, 85 microns, consistent with nickel-iron composites, the same alloys used in spacecraft heat shielding. At the European Southern Observatory in Chile, a team compared polarization data from both objects. The polarization angle of the twin rotated precisely in sync with 3I Atlas's axial spin, maintaining a constant phase offset. That meant the two shared not only trajectory but orientation, one turning fractionally after the other, like a dancer echoing its partner's movement half a step behind. Back at Nancy, the scientists attempted to simulate this coordination. They built a model in which the second body acted as a sensor array, mirroring the first's emissions to stabilize its course. The simulation produced a result eerily close to the observed behavior. The energy required for such precision, however, exceeded any known natural process by several orders of magnitude. A few researchers, more cautious than curious, proposed a simpler explanation. Optical interference between the comet's coma and its ion tail could generate a ghost image, a spectral mirage. But when Webb repeated the scan 2 weeks later, the second spectrum was still there. Same shape, same rhythm, same 7-minute delay. Mirage or not, it refused to vanish. Then something changed. During a solar flare on July 14, both spectra fluctuated simultaneously, but the twins' curve reacted first. It dimmed a full 30 seconds before 3I Atlas showed any response. For the first time, the follower anticipated the leader. That single anomaly shattered the sequence of assumptions holding the theory together. The twin wasn't merely reflecting, it was predicting. Across observatories, the phrase spectral twins began to circulate in memos and encrypted Slack threads. Scientists stopped calling it Atlas B. They called it the mirror. Marchand summarized it best during a private briefing. Two objects, sharing one chemistry, one pulse, one geometry. One burns under sunlight, the other hides in shadow yet feels the same heat. By the end of that week, the question was no longer what the twin was made of, but why it existed at all. Because in physics, perfect copies do not persist for long, unless they're being kept that way. By late July 2025, the team at the Jet Propulsion Laboratory began to notice something they couldn't categorize. The orbital path of 3I Atlas, once thought to be as predictable as any interstellar visitor under solar gravity, had started to drift. Not wildly, subtly, almost deliberately. Each deviation was minute, a few arcseconds here, a millisecond shift there, but the pattern was unmistakable. Every few hours, the comet's trajectory would realign, pulling itself back toward the same invisible corridor through space. And each time that happened, 7 minutes later, the twin followed suit. The first correction went unnoticed. The second was flagged as an error. But by the 5th, on July 21st, the probability of coincidence fell below 0.01%. Astrophysicists at the European Space Operations Centre plotted the displacements against time and found something extraordinary. The adjustments matched the gravitational vectors of nearby planets before those planets exerted influence. In simple terms, the object was compensating in advance, anticipating perturbations that hadn't yet occurred. The scientists called it preemptive stabilization. Engineers called it impossible. 3I Atlas wasn't drifting through gravity. It was navigating through prediction. When NASA compared these changes to historical data from Oumuamua and 2I divided by Borisov, the only other known interstellar visitors, the contrast was glaring. Oumuamua had displayed mild non-gravitational acceleration due to outgassing, yes, but it was erratic, non-repeating. 3I Atlas, however, exhibited precision. Its microbursts of velocity were consistent in both magnitude and timing, and more importantly, reproducible. Goldstone radar picked up corresponding energy spikes, pulses lasting less than 4 seconds, each releasing the equivalent of several tons of sublimated CO2. The emissions weren't random jets. They were controlled thrusts, and they always fired at the same rotational phase angle, as if obeying a program. The Nancy Observatory confirmed that each adjustment altered 3I Atlas's course by only fractions of a degree, yet those fractions accumulated into a deliberate vector shift. Mars. Every projection, no matter the model used, led to the same point, a near encounter with the Martian equatorial plane, inside what ESA analysts began calling the Red Corridor. Still, the most confounding discovery came from the timing. Every single course correction was echoed precisely 7 minutes and 12 seconds later by the twin. The delay never changed. Not once. The twin's path mimicked every maneuver, matching acceleration, deceleration, and angular momentum with eerie precision. And yet, the twin itself never showed evidence of active thrust. No jets, no plume, no visible outgassing. It moved as though responding to the first object's intent, like a reflection obeying motion before physics had time to notice. At the Institute of Celestial Mechanics in Paris, a young orbital dynamicist named Omar Khoury suggested that the twin might be functioning as a kind of anchor, a stabilizing counterweight that kept the primary on its vector. In classical terms, it was like watching two pendulums sharing one string, oscillating together. But in quantum terms, some argued, it resembled entanglement. Whatever the mechanism, the behavior seemed less like reaction and more like dialogue. One led, one replied, one burned, one absorbed. When the corrections began to tighten with intervals shrinking from hours to minutes, it became clear that 3I Atlas was preparing for something. Its orbit was no longer a passive fall, it was choreography. ESA's control room went silent on the night of July 28th. The live telemetry feed showed a rapid acceleration spike, followed by a sudden stabilization. The comet's new trajectory brought it within 0.0007 AU of Mars's orbital path, closer than any natural interstellar object had ever ventured. And then, right on cue, 7 minutes later, the twin matched speed, position, and vector, as though tethered by invisible logic. Dr. Dubray, watching from Nancy, whispered what no one dared to put in a report. "It's not falling. It's aiming." The words stuck. For the first time since the discovery, the language of physics began to give way to the language of intention. Because objects don't aim. They obey gravity. The pattern began like a heartbeat. At first, it was buried inside layers of radio noise, small spikes in energy recorded by the Nancy Observatory's deep space receivers. The bursts came every 7 minutes and 12 seconds, too regular to be random and too faint to be solar interference. Then, on August 3rd, 2025, the James Webb Space Telescope captured the same pulse visually in the infrared spectrum. Twin flashes, identical in intensity, separated by the same constant rhythm. 2 signals, 2 origins, 1 cycle. The researchers labeled it EP721, shorthand for energy pulse, 7 minutes, 12 seconds. But the nickname that caught on among the team was simpler, almost reverent: the heartbeat of 3I Atlas. When scientists compared datasets from different observatories, Webb, Goldstone, Nancy, and the Deep Space Network, they realized the pulse wasn't just a local emission. It propagated through space like a ripple, visible in electromagnetic and particle fluxes simultaneously. Solar wind particles accelerated and decelerated in perfect harmony with the bursts, as if the object were breathing through the plasma around it. What made the phenomenon even stranger was the phase delay between the primary and its twin. The comet pulsed first. The twin answered 7 minutes later, echoing the same waveform, down to the microsecond. The interval never changed, even when 3I Atlas accelerated toward the inner solar system. That kind of precision shouldn't be possible in nature. The twin wasn't just reflecting energy, it was receiving it and sending it back. At the European Space Operations Centre, physicists attempted to calculate the power behind the bursts. Even at its weakest, each pulse carried the equivalent of a small thermonuclear detonation, around 70 megatons of released energy, but without any observable mass loss. There was no visible gas venting, no debris, no ion plume. The energy appeared, shaped itself into a pulse, and vanished again, leaving no trace. Non-destructive emission, the report said. Output without source. For comparison, comets release energy through sublimation of frozen gases under solar heat, a process chaotic and diffuse. What 3I Atlas exhibited was measured, mathematical, and impossibly consistent. The energy wasn't random, it followed a waveform that mirrored the Fibonacci sequence when plotted against frequency drift. Some joked that the universe itself was sending a pattern in code. Others weren't laughing. At Caltech, data analysts tried to decode the waveform as binary, mapping high and low energy phases into ones and zeros. The message they extracted was short, repeating 101101, pause, 101101. It didn't translate to anything recognizable, but in atomic notation it corresponded to carbon and oxygen, the essential elements of life. The same symbols had appeared weeks earlier in the spectrographic data, forming a recurring theme that now seemed deliberate. By mid-August, scientists realized that the pulse had effects far beyond electromagnetic readings. Magnetometers on the Mars Reconnaissance Orbiter detected synchronized oscillations in the planet's upper ionosphere, the minute fluctuations in magnetic density that rose and fell with the pulse frequency. The planet was literally responding, resonating in phase with the incoming signal. A few researchers began whispering what none dared publish. Mars was being tuned. Then came the strangest finding of all. When the energy bursts were converted to audio frequencies, the waveform produced a sound low, rhythmic, almost human. Some described it as a heartbeat, others said it sounded like breathing through metal. In controlled lab environments, volunteers exposed to the translated sound reported a shared experience, a feeling of motion, of synchronization, as if their own bodies had begun to match the rhythm. It was a coincidence, psychologists said, a trick of suggestion, but the timing was impossible to ignore. The same moment the twins' pulse intensified, the red dust storms on Mars began to swirl in repeating, spiral patterns visible from orbit rotating exactly every 7 minutes. Dr. Dubray summarized it in a single line during a midnight briefing. The comet sends, the twin responds. Mars vibrates. If that pattern was intentional, it meant the pulse wasn't just energy. It was communication. A message written not in light or language, but in rhythm. A universal constant that every living system, from heart to planet, could understand. And if the timing was by design, then somewhere behind that cold interstellar visitor was an intelligence fluent in the oldest language of all. Pulse and pause. Life and silence. The first signs of magnetic interference didn't come from light. They came from wind, the charged, invisible kind that fills the void between planets. By mid-August 2025, the Parker Solar Probe began transmitting irregular readings. The solar wind's magnetic field, usually chaotic, shaped by solar rotation and coronal bursts, had become strangely ordered. Every 7 minutes and 12 seconds, the polarity flipped. North, south, north again. Perfect timing. At first, NASA's heliophysics division blamed a calibration error, but within 48 hours, the same pattern appeared in data from the Solar Orbiter and the Bepi-Colombo mission near Mercury. 3 separate spacecraft, all at different points in the inner solar system, were hearing the same rhythm from the same direction, the corridor of 3 I Atlas. When analysts overlaid the data, the precision was unnerving. The oscillations aligned exactly with the already known energy pulse cycle. Every reversal matched the comet's heartbeat. The solar wind wasn't carrying random turbulence anymore. It was carrying a signature. At the European Space Operations Centre, a task force of plasma physicists tried to reconstruct the source. If 3I Atlas were expelling ionized gas, it could, in theory, sculpt magnetic bubbles. But the strength required to synchronize 3 probes millions of kilometers apart was astronomical, far beyond any natural discharge. The simplest explanation no longer fit. Then, a discovery. Mars-orbiting satellites, Mars Express and Trace Gas Orbiter, detected a secondary field approaching from deep space. It wasn't strong enough to disrupt instruments, but its structure was the inverse of 3I Atlas's known polarity. The field lines curved inward, like a mirror image drawn in magnetism. The realization came quickly. The second object, the so-called twin, wasn't just following the comet's orbit. It was complementing its field. Together they formed a magnetic loop, opposites balanced across a vacuum, sustaining each other like 2 poles of a single unseen mechanism. ESA engineers ran models to test how such a configuration could remain stable. The answer, disturbingly, was feedback. 2 coherent fields could, under perfect timing, exchange energy indefinitely, feeding and correcting each other without loss. A magnetic echo chamber. But for that to occur, one of them had to think. One had to sense the imbalance before it happened, and compensate precisely at the right moment. The twins' polarity reversals always came a fraction earlier, as if it anticipated what Atlas would do next. Soon, researchers began referring to the pair as a magnetic binary, not a physical tether, but a system joined through flux. Each pulse from Atlas created a ripple. Each response from the twin erased it. a self-healing circuit, invisible yet vast. Outside the simulation rooms, the effect was spreading. A standing wave seemed to form between the pair and Mars, a low-frequency hum vibrating through the planet's magnetotail. For planetary scientists, this was the turning point. Mars, an almost magnetically dead world, shouldn't have responded to anything. Yet its faint remnant field began to oscillate, synchronizing to the same 7-minute period. Something in the interaction between comet, twin, and planet had closed a larger circuit. By August 28th, the data left little room for interpretation. The twin wasn't reflecting light, or trailing debris, or drifting passively through space. It was conducting energy balancing and redistributing magnetic pressure across tens of millions of kilometers with mechanical precision. No known natural object could do that. In a single month, 3I Atlas had gone from a comet to a transmitter, and its companion, the silent, invisible twin, had become its receiver, its regulator, and perhaps its reason for staying stable at all. The solar system's magnetic field, once ruled only by the sun, now had 2 new voices humming in perfect phase. By the first week of September 2025, the mystery surrounding 3I Atlas deepened in a way no one expected. The discovery didn't come from high-energy sensors or radio telescopes this time, but from something deceptively simple: dust. Comets are messy travelers. As they near the sun, heat causes their frozen interiors to erupt, throwing out gas and dust that form long, chaotic tails. That's how scientists read their composition, by the color, density, and spread of that debris. But when the Hubble Space Telescope aimed at 3I Atlas to capture its developing coma, the image contradicted every model of cometary behavior known to astronomy. The dust wasn't drifting. It was staying. The photographs showed a narrow filament extending backward from the nucleus, a thread of reflective particles perfectly aligned with the comet's motion. Instead of expanding and dispersing under solar radiation pressure, the stream held its shape like a frozen river of glass. The more Hubble zoomed, the stranger it appeared. Grains of silicate and carbon clustered into uniform chains, evenly spaced, locked into formation. At first, astrophysicists thought the data must be an optical illusion, a trick of angle or overexposure. Yet repeated observations from the Subaru telescope in Hawaii and the Very Large Telescope in Chile confirmed it. Even more unsettling, the filament connected directly to the coordinates of the twin. What everyone had assumed was empty space, just the dark corridor. Trailing behind 3I, Atlas was filled with ordered dust, spanning millions of kilometers. When the comet shifted, the filament flexed but didn't fragment. When solar flares swept through, it absorbed the radiation and returned to its exact shape within hours. In natural conditions, dust behaves like fog. Here it behaved like fiber. Dr. Omar Khoury, the orbital dynamicist from Paris, attempted a particle simulation to explain it. His models required the dust grains to be charged and rotating in synchrony with an alternating magnetic field, the same magnetic inheritance pattern detected weeks earlier. When the twins' magnetic polarity flipped, the particles flipped too, aligning themselves along invisible lines of force. In his notes, Khoury wrote, "If 3I Atlas and its twin form the poles, then this dust is the wire between them." The term plasma tether entered the internal ESA report soon after. At the same time, polarization analysis revealed something even harder to dismiss. The light reflected by the filament carried a faint spiral polarization signature. Right-handed spin near 3I Atlas, left-handed near the twin. In physics, such dual chirality indicates organization on a molecular scale. It's not random scattering, it's structured rotation. In biology, that property is the hallmark of amino acids. In space, it had never been recorded before. When researchers overlaid the dust's polarization pattern with the timing of the 7-minute pulse, they noticed that every cycle corresponded with a subtle rearrangement inside the filament. It wasn't static, it was rebuilding itself, particle by particle, as though constantly reprinting a message in the vacuum. Then came the most astonishing observation. During one of Webb's mid-infrared sessions, a segment of the filament near the midpoint briefly glowed, not as a reflection, but as an emission. The dust itself radiated heat for less than 10 seconds before cooling again. When analysts decomposed the spectral spike, they found traces of complex silicates doped with metals, nickel, chromium, and even traces of rare earth elements. None of them should exist in such concentrations in cometary debris. The conclusion spread quietly through encrypted channels. The filament wasn't merely debris at all. It was a conduit, stabilizing both bodies through electromagnetic feedback. Still, one final anomaly kept the scientists awake. The filament didn't trail behind 3I Atlas in the usual cometary sense. It followed the exact orbital curvature, maintaining a fixed distance between the comet and the twin. No centrifugal spread, no lag, no decay. Even as the comet accelerated toward Mars, the tether shortened proportionally, holding a constant ratio as if bound by an equation. By September 8th, the European Southern Observatory released an internal chart plotting the filament's shape against gravitational perturbations from Mars and the Sunday. The line barely moved. In mathematical terms, it was an impossible equilibrium, a configuration no dust-tail could ever sustain without artificial control. To the public, nothing was announced. The official report spoke of anomalous stability and particulate outflow, but inside the private forums of astrophysicists and plasma engineers, the tone shifted. The twin wasn't just shadowing 3I Atlas, it was linked to it physically, magnetically, maybe even mechanically. And that meant one terrifyingly simple thing. If the dust didn't drift, then someone, or something, was keeping it exactly where it was supposed to be. Silence is not absence. In astronomy, silence is data, the background hum of the cosmos, the faint radio wash of dying stars, the crackle of solar static that fills every empty frame of observation. But when 3I Atlas approached Mars, something unprecedented occurred. For the first time in recorded deep space telemetry, the silence itself went missing. The discovery began with confusion at the Deep Space Network in Madrid. Late one night, an engineer monitoring signal drift from the Goldstone array noticed a blind spot. A narrow band of frequencies where background noise should have been, but wasn't. The gap wasn't caused by interference or overload. It was a true null, a hole in the cosmic static. He ran a diagnostic. Then another. The silence moved. When plotted, the gap traced a perfect arc across the same coordinates as the twin of 3I Atlas. That invisible companion locked 0.07 AU. Behind, the anomaly wasn't fixed in space. It travelled with the twin like an acoustic shadow. By the next morning, the same phenomenon appeared in data from Canberra and New Norcia. Every antenna aimed at the region saw the same erasure. A travelling void that swallowed background radiation and returned nothing. Scientists began calling it the quiet line. At first, ESA assumed a hardware issue. Microwave filters, faulty amplifiers, even atmospheric interference were checked. But when independent amateur arrays in Japan and Chile recorded the same band of silence from Earth's surface, the cause could no longer be blamed on equipment. Something in deep space was absorbing soundless light. Spectrographic scans confirmed the strangest detail of all. Photons passing through the twin's trajectory lost a fraction of their polarization. Not absorbed, not scattered, simply cancelled, as if their oscillations had been flattened into stillness. This wasn't the behavior of a solid object, it was the behavior of a field. Dr. Omar Khoury described it as a coherent sync. Every wavelength entering the region was dampened in perfect ratio, producing what he called active quiet. It wasn't an absence of signal, it was a force that consumed signal and left nothing behind. Meanwhile, NASA's magnetospheric multiscale mission, positioned farther along the Sun-Mars line, detected a subtle echo each time the void passed through a plasma stream. The echo wasn't electromagnetic at all. It was phase inversion, a mirror reflection of energy, re-emerging exactly 7 minutes after absorption. The delay matched the rhythm of 3I Atlas's pulses. Something was taking in energy, holding it, and releasing it on time. The next revelation came from the James Webb Space Telescope. Its near-infrared spectrometer recorded faint diffraction halos around the twins' supposed position patterns, identical to light reflected off smooth, curved metal. But instead of brightening the surrounding sky, the reflections darkened it, bending radiation inward rather than scattering it outward. Webb's optical team described it as negative reflectivity. It behaved like a mirror that doesn't shine a surface that absorbs light in order to project silence. This was more than strange physics. It was information control. If 3I Atlas emitted rhythmic bursts and the twin responded by silencing a region of space, the two together might be operating as a transmitter and modulator, one speaking, the other muting the background to ensure the message could be heard. To test this theory, the Deep Space Network synchronized antennas across 3 continents, creating an artificial baseline spanning Earth's diameter. For one brief hour, they listened not to 3I Atlas itself, but to the void that followed it. The readings showed periodic micro-fluctuations inside the silence patterns of subtraction, repeating every 7.12 minutes, precise to the millisecond. Within those fluctuations was structure, encoded in negative space, amplitude variations traced a harmonic ladder, prime intervals 2, 3, 5, 7, 11, a mathematical fingerprint. It was as if the silence carried a sequence of thought, not spoken through emission but through removal. Dr. Dubray summarized it with quiet disbelief during a midnight briefing. It's communicating by not existing. From that night on, the twin was no longer described as a shadow or reflection. In internal memos, its new designation appeared, the absorber, and wherever it moved, the universe itself seemed to dim, as though even light had learned when to stay quiet. By the second week of September 2025, something remarkable began to happen on Mars, not in its skies, but beneath its surface. At first, it came as a glitch. The European Space Agency's Trace Gas Orbiter detected low-frequency vibrations reverberating through the thin Martian atmosphere, tiny variations in air density, recurring every 7 minutes and 12 seconds. The exact interval of the 3I Atlas pulse. The data analysts assumed interference from the orbiter's own thrusters, but cross-checks with NASA's InSight seismometer, still transmitting intermittent packets from Elysium Planitia, told a different story. The ground itself was shaking in rhythm with a signal coming from space. The tremors were subtle, too weak to be tectonic, too precise to be natural. Each pulse began with a faint electromagnetic rise in the ionosphere, followed by a pressure wave that rippled through the regolith and dissipated after several seconds. On a planet considered almost geologically dead, that was impossible. At JPL, researchers replayed years of InSight archives. The old logs contained nothing like this. The rhythm had appeared only recently, just as 3I Atlas began crossing Mars's orbital plane. Something was waking the planet up. When the data reached CNES in Toulouse, plasma physicists compared it with the twin's magnetic readings. Every pulse from the twin corresponded to a measurable fluctuation in Mars's magnetic tail, the faint, elongated remnant field that still lingers behind the planet as it faces the solar wind. The oscillations weren't random, they carried harmonic symmetry, as if Mars itself had become a resonator within the binary system of Atlas and its shadow. Then the microphones started listening. On September 14th, the Russian ExoMars lander prototype a still-operational seismic station near Oxyaplanum recorded infrasonic waves too deep for human ears. The pattern wasn't continuous, but stepped, like a coded transmission. When the frequencies were converted to the audible range, the sound resembled a faint, rhythmic hum, a low tone that built, paused, and built again. ESA technicians called it the Martian heartbeat. The real surprise came when the same rhythm was detected on the opposite side of the planet. 2 rovers, Perseverance in Jezero Crater and China's Zhurong in Utopia Planitia, both picked up identical magnetic spikes through onboard sensors. The time difference between detections was precise enough to triangulate a source, somewhere near the equatorial region, deep under the crust. Geologists ran subterranean radar scans. The reflection profiles revealed cavities long, cylindrical voids stretching for kilometers beneath the surface, filled not with rock or ice, but with material of unknown dielectric constant. When radar waves hit it, they didn't bounce back. They slowed down, as if traveling through dense plasma. NASA scientists proposed a possibility that no one dared to say aloud in the early briefings. The planet might be responding to 3I Atlas's signals, but not passively. The frequency match was too precise. Every emission from the comet and its twin produced a delayed echo from Mars, timed to the same 7-minute interval. It wasn't reflection, it was reply. On September 18th, the Mars Reconnaissance Orbiter pointed its high-rise camera toward the Olympus Mons caldera. What it recorded left analysts stunned. Faint infrared flickers appeared inside the volcano's central vent, synchronized exactly with the 3I Atlas pulse sequence. Olympus Mons, silent for eons, was radiating heat in perfect time with an interstellar signal. Theorists began to panic quietly. The mountain's frequency spectrum mirrored that of the comet's emission, down to decimal precision. Some said it could be coincidence, a mathematical resonance between two oscillating systems. Others whispered the unthinkable. Olympus Mons wasn't reacting, it was receiving. The Martian atmosphere added one final twist. For the first time since measurements began, its ionosphere displayed standing waves that formed a grid pattern over the planet's night side. Geometric, coherent, like an invisible circuit map. Each node pulsed faintly at the same rhythm as the twin. Dr. Dubray summarized it in a report that was never released to the public. Mars has entered the equation. It was as if the twin and the comet had been waiting for the planet to respond for its dormant fields, minerals, and thin electric atmosphere to resonate again. Now, with every passing hour, that resonance grew stronger, as if Mars was no longer merely being observed, but being activated. By late September 2025, as 3I Atlas drew closer to Mars, the data began forming a pattern not in numbers or signals this time, but in geometry. The comet's tail, its dust filament, even the faint plasma arc surrounding its twin, all were shaping themselves into something nature rarely builds by accident: order. The first to notice was a postdoctoral researcher at the European Southern Observatory, who ran a high-contrast filter across a set of images captured by the Hubble Space Telescope. She expected to see random turbulence in the dust, a tangled wake of ice and charged particles. Instead, she saw spirals, concentric arcs, coiling outward in perfect logarithmic proportion. When she overlaid a standard Fibonacci spiral template, the match was nearly exact. One spiral emerged from 3I Atlas's luminous coma, the other from the coordinates of its shadow. Two curves, offset by 0.07 AU, intersecting mathematically at one point. Mars. It was a coincidence so elegant it didn't look random at all. ESA's imaging division ran simulations to test whether solar wind pressure or gravitational resonance could have sculpted the formation. They couldn't. Cometary dust expands chaotically, driven by heat and drag. What the images showed wasn't expansion, it was coordination. The filaments thickened and thinned at Fibonacci intervals. 1, 1, 2, 3, 5, 8. Each arc spaced according to the same ratios found in galaxies, hurricanes, and DNA helices. This wasn't just beauty. It was structure. A mathematical rhythm written in dust. When the James Webb Space Telescope turned its NIRCam toward 3I Atlas's coma, the team noticed something even stranger. The spiral was pulsing. Every 7th minute, the inner arcs brightened in a rolling wave, as though the comet's light itself were breathing in sequence with the energy pulse already known from previous chapters of data. At the Institute of Celestial Mechanics in Paris, Dr. Khoury and his colleagues analyzed the waveform patterns, converting the intensity variations into frequency ratios. The result was stunning. When translated into sound, the data produced a rising tone that repeated in perfect golden ratio intervals, the same proportion that governs Fibonacci growth in natural systems. It's not random emission, one engineer said quietly. It's resonance. The concept rippled through the community. What if 3I Atlas wasn't simply moving through space, but was organizing it aligning dust, plasma, and magnetic flux into self-similar spirals the way life organizes molecules into symmetry? At NASA's Goddard Space Flight Center, a small group of physicists went further. They modeled how two bodies, one emitting pulses, the other absorbing them, could create standing waves in the interplanetary medium. The result produced fractal density rings that naturally obeyed Fibonacci ratios. In other words, the shape wasn't decorative. It was the physical footprint of communication. The twin and the comet were writing in geometry. When the Mars Reconnaissance Orbiter passed over the northern plains, the surface itself began to mirror the same rhythm. Dust storms near Utopia, Planitia, spun into matching spiral configurations, vast, thin vortices maintaining exact angular distances. They rotated every 7 minutes, just like the pulses. Coincidence stopped being a viable word. By September 25th, spectral analysis of sunlight reflecting off the dust spiral revealed alternating regions of high and low refractive index, microscopic layering that implied stacking, like encoded binary rings. It was as if the spiral wasn't just following Fibonacci ratios, but was using them a universal constant as carrier signal. The implications were staggering. In mathematics, the Fibonacci sequence is nature's shorthand for efficient growth. In biology, it's the blueprint of replication. In wave mechanics, it's stability under chaos. If 3I Atlas and its twin had built such a pattern intentionally, it might represent a form of communication so old and fundamental that it doesn't require language-only proportion. Dr. Marchand from CNRS described it in a line that later leaked from a private memo. If this spiral is deliberate, it's not art, it's instruction. When the images were compiled into a time-lapse, the spirals appeared to converge toward a single invisible point, an epicenter not in space, but in time. The final frames showed both spirals tightening simultaneously, their luminous bands collapsing toward the same ratio, as if winding down to a conclusion. That moment, analysts calculated, would occur on October 29th, 2025, the day 3I Atlas would make its closest approach to Mars. The Fibonacci pattern, it turned out, wasn't decoration on a comet's tail, it was a countdown. It began with noise, an ocean of static so dense that, for weeks, nobody realized it wasn't noise at all. By late September 2025, data centers across Europe and the United States were drowning in telemetry from the Deep Space Network. Every telescope tuned to 3I Atlas was feeding terabytes of raw signal into storage, most of it unreadable. Analysts saw only overlapping spikes, plasma interference, and timing pulses from the twin. But hidden beneath that chaos, there was structure subtle, repetitive, too orderly for randomness. It was a graduate student at the California Institute of Technology who found the key. While cleaning corrupted spectrographic data, she noticed that every spike in the radio waveform contained smaller, nested spikes, harmonic echoes spaced at exact intervals matching atomic numbers: 6, 8, 14, 26, carbon, oxygen, silicon, iron, the same elemental series that had appeared in the Fibonacci dust ratios. She applied a compression algorithm, the same one used to clean deep space signals from Voyager, and the noise condensed into a digital grid. What emerged wasn't random flux, it was binary. Ones and zeros woven through amplitude modulation, embedded directly inside the comet's electromagnetic pulse. 3I Atlas wasn't just radiating light, it was encoding information. When the same method was applied to the twins' echo, the binary pattern inverted perfectly, as if one body were the question and the other the answer. Together, they formed a data pair transmission and confirmation looping endlessly across the void. The CNES Computing Center in Toulouse built a custom decoder to interpret the pattern. At first, they treated it as simple base 2 data, hoping for recognizable ASCII text or mathematical constants. But the translation yielded nothing legible, only sequences of recurring ratios. When plotted visually, the ratios formed spirals, Fibonacci spirals. Again, then someone tried something radical. Instead of decoding it as language, they processed it as image data. The binary stream, converted into grayscale pixels, produced faint geometric shapes, concentric circles, radiating lines, and what looked like a molecular lattice. The patterns repeated every 7 minutes and 12 seconds, the same rhythm as the energy pulse. Each frame was a snapshot not of space, but of structure. It looked like the schematic of a circuit board. Over the next few days, data centers from ESA, NASA, and JAXA collaborated through encrypted channels to piece together longer sequences. When stacked sequentially, the images began to morph, shifting from molecular grids to complex three-dimensional formations. What appeared to be a spiral arrangement of nodes converged into the unmistakable silhouette of an orbit. The orbit of Mars. It was no longer possible to call this a coincidence. The message, if it was one, seemed to contain instructions built from physics itself, encoded through motion and magnetism. The binary patterns translated into coordinates that aligned precisely with the latitude and longitude of Utopia Planitia, the same Martian basin where earlier signals had been detected. At that point, the conversation in the control rooms changed tone. Scientists stopped asking if 3I Atlas was transmitting. They began asking to whom. A private memo circulated inside the European Space Agency's data division outlined 3 possibilities. The data is an autonomous navigation code. The comet is self-guiding. The data is a handshake protocol, a system pinging for acknowledgement. The data is legacy, a transmission meant to trigger something that already exists. Of the 3, the third explanation matched the evidence best, because when analysts mapped the timing of each binary emission against Mars's own return pulses, they found a staggering result. The delay between transmission and response was shrinking. With each passing day, the Martian echo came back faster, as if whatever was receiving the signal on the planet was beginning to understand the format. Then came the final discovery. In one of the longer data sequences, near the end of a 7-minute cycle, a single block of binary repeated 3 times in rapid succession. When decoded through base 16 translation, it formed one string recognizable to every scientist who saw it. ASCII code for 4 letters, Mars. The transmission stopped for exactly 7 minutes. Then both 3I Atlas and its twin pulsed once, simultaneously, brighter than they ever had before, a double flare seen from every observatory on Earth. The data stream resumed, but it was different. The repeating sequence was gone. The binary patterns no longer looped. They were evolving. 3I Atlas had sent its message. And now, Mars was answering in real time. By the end of September 2025, the conversation around 3I Atlas had shifted from astrophysics to something older geometry. Not the kind drawn on blackboards, but the kind carved in stone. The first connection came from a historian, not a scientist. While reviewing orbital alignment data, she noticed that on October 29th, the date of 3I Atlas's closest approach to Mars, the line between the comet, the twin, and the Sun would form a 23.5 degrees inclination relative to the ecliptic. That angle wasn't random. It was the same as Earth's axial tilt, the same number encoded into countless monuments built by ancient civilizations who worshipped the sky. At first, no one took it seriously. Angles recur in nature. Coincidences happen. But when a team at the Institute of Celestial Mechanics in Paris began running cross-comparisons, the pattern refused to disappear. The comet's orbital geometry didn't just pass near Mars, it mirrored alignments that appeared across human architecture and mythology. Stonehenge, the Great Pyramids, the Nazca Lines, even the megalithic circle at Nabta Playa in Egypt, all shared one geometric constant, 23, 5 degrees. It was the ratio between Earth's equator and the Sun's seasonal path, the measure that defined solstices, equinoxes, and every rhythm by which early humans tracked time. Now, that same ratio governed the descent of a comet from another star system. The scientists tried to rationalize it. Maybe 23.5 degrees was simply the most stable angle for solar approach. Maybe gravitational harmonics favored it. But the more they calculated, the less sense it made. For an interstellar object entering our solar system from random direction, the probability of matching Earth's axial tilt was less than 1 in 10 million. It wasn't the first time 3I Atlas had seemed to know where it was going. But this felt personal. Researchers from the CNRS plotted every major alignment 3I Atlas would pass through on its journey. Earth, Mars, the Sun, and the twin following behind. When the data was visualized in 3 dimensions, the lines intersected not in space, but in ratios. Each angle between objects conformed to harmonic intervals 1 to 2, 2 to 3, 3 to 5, the same proportions found in musical tuning systems and sacred geometry. The system wasn't random motion anymore. It was architecture. NASA's orbital analysts reluctantly confirmed the findings. The comet's trajectory was locked in a harmonic sequence that repeated every 23.5 days, each cycle forming a new geometric figure relative to the inner planets. First a triangle with Earth and Mars, then a pentagon with Venus, then a hexagon with Jupiter's distant resonance. In mythology, these figures were once called celestial sigils, patterns used by ancient astronomers to mark cycles of conjunction. But now, in 2025, they were being drawn again, not by priests, but by a machine moving through space, as if something out there still remembered the geometry humanity had long forgotten. The archaeometric team at the Sorbonne compared satellite images of Mars's surface with those geometries. One feature stood out: a circular depression in Utopia Planitia, 3.5 kilometers wide, surrounded by spiral ridges arranged in Fibonacci proportion. Its central ridge angled precisely 23.5 degrees toward Mars's north pole. It was a mirror, a planetary-scale compass pointing to the same cosmic tilt that shaped Earth's seasons. If this was coincidence, it was layered. The depression matched one of the harmonic intersections predicted in 3I Atlas's projected path. In other words, the comet and the planet were aligning not just spatially, but symbolically, as if completing a figure begun long before humans could calculate it. By October 2nd, the data had reached the Vatican Observatory. Quietly, their astrophysics division issued an internal memo: historical patterns recurring in orbital geometry, potential significance beyond scientific domain. Meanwhile, on the internet, a new theory caught fire, that 3I Atlas was not drawing new lines across the solar system, but retracing old ones. The same cosmic grid mapped by ancient civilizations thousands of years ago. The thought unsettled even the scientists. If true, it meant the geometry came first. The monuments on Earth were echoes of something the sky had already written. The 23.5 degrees alignment was no longer a number. It was a signature. When plotted over time, the comet's approach traced an invisible helix through the inner solar system. A spiral that would reach perfect symmetry on October 29th, the moment it crossed the Martian plane. From above, the orbit resembled the symbol carved into Sumerian tablets to represent the teacher star. The ancient world had once believed knowledge came from the heavens. Now, as 3I Atlas's path tightened toward Mars, it was hard not to wonder if that belief had been memory instead of myth. And when the twins' signal dimmed briefly on the night of October 3rd, as if pausing mid-pulse, the timing was exact the moment the 23.5 degrees line reached completion. Somewhere between geometry and intent, silence and design, the universe had just drawn its next angle. Heat, in space, behaves predictably. The closer an object moves toward the sun, the warmer it becomes. That's physics, immutable, unquestioned. But in October 2025, when 3I Atlas entered its closest phase to Mars, that law began to fracture. The anomaly appeared first in thermal readings from the Mars Reconnaissance Orbiter. Its infrared spectrometer detected an abrupt temperature drop not in the Martian atmosphere, but in open space, directly behind the comet's tail. The cooling wasn't gradual, it was surgical. A narrow band, stretching millions of kilometers, fell by more than 40 degrees Kelvin in under 10 minutes. At the same moment, the James Webb Space Telescope captured parallel data. A second, weaker emission line in the far infrared, something radiating less heat than the background vacuum. It wasn't just cold. It was colder than space itself. Webb's imaging algorithms flagged it as a processing error, but when the Deep Space Network cross-referenced the readings with radio data from Goldstone and Canberra, the signal repeated, precisely at the position of the twin trailing behind 3I Atlas. Whatever followed the comet wasn't heating up under solar radiation, it was absorbing it. ESA thermal engineers ran the numbers again. To maintain such a temperature gradient, the twin would need to be converting nearly 90% of incoming radiant energy into another form, magnetic, kinetic, or something unknown. No known material could perform that kind of conversion. Even graphene or metamaterials cooled by quantum tunneling couldn't achieve a coefficient that extreme. The twin wasn't reflecting sunlight, it was devouring it. By October 8th, NASA's Parker Solar Probe recorded a correlated dip in particle velocity inside the solar wind itself. The stream slowed near the trajectory of 3I Atlas, as if space around the comet had become viscous, a thermal drag effect. Plasma physicists described it as a localized entropy sink. Energy wasn't being scattered, it was being organized out of existence. At the Jet Propulsion Laboratory, simulations revealed something more unnerving. Every time 3I Atlas emitted one of its 7-minute pulses, the temperature around it rose sharply, but the twins' region dropped by the exact same amount. The two objects weren't only synchronized in motion, they were exchanging heat. As though one exhaled energy, the other inhaled. The effect was so balanced that the total thermal sum across the system remained constant. One burned, the other cooled. Two halves of a thermodynamic equation. If natural, it was unprecedented. If artificial, it was deliberate design. Then came the revelation from Mars. The ExoMars Trace Gas Orbiter detected faint infrared flickers inside Olympus Mons's caldera. Minute thermal surges, corresponding exactly with each pulse from 3I Atlas. The volcano, dormant for millions of years, was warming up in the same rhythm that the twin was cooling down. To geologists, that correlation was staggering. Olympus Mons was absorbing what the twin released. The pattern completed a closed loop. Energy moved from comet to twin, to Mars and back again, maintaining perfect thermal balance across tens of millions of kilometers. One ESA scientist wrote in a private log, "We are watching an interplanetary circuit stabilize itself. As the data grew denser, the paradox sharpened. Every physical rule that governs heat said this system should collapse. Energy should dissipate. Radiation should scatter. Instead, the twin's presence kept everything stable. It maintained a temperature lower than the cosmic microwave background, yet emitted structured pulses that behaved like timed exhalations of entropy. When translated into waveform analysis, those exhalations revealed a repeating thermal signature, a fractal decay pattern based on Fibonacci intervals. The ratio appeared again, woven into heat itself. At 2:14 UTC on October 10th, an automatic spectrometer aboard James Webb caught an image that made the team fall silent, a halo of faint blue light surrounding the twins' position. The glow was invisible to optical sensors but bright in thermal contrast. It wasn't illumination, it was negative radiation, the visual imprint of heat being removed from space. Moments later, Mars's surface temperature in Utopia Planitia rose by precisely 0.07 degrees Kelvin, the same ratio as the distance separating 3I Atlas from its twin, 0.07 AU. The entire system seemed to be locked in perfect thermodynamic symmetry, as though one object existed to erase what the other created. This was no longer cometary behavior. It was regulation. By mid-October, a new hypothesis spread quietly through the closed channels of ESA, CNES, and JPL. What if the twin wasn't an independent body at all, but a stabilizer, a failsafe designed to maintain equilibrium during a planetary event? No one could say what that event was, but with every passing hour, 3I Atlas's radiation output increased, and the twins' cold envelope deepened, each responding to the other like partners in a single biological function, something alive in physics, not conscious, but balanced. A machine that didn't burn to survive, it cooled to exist. By mid-October 2025, a growing unease spread through every observatory on Earth. 3. Atlas was now less than 2 weeks from its closest approach to Mars, and all major instruments orbital, ground-based, and deep space were trained on the same region. Yet the most extraordinary event wasn't happening in the comet's tail, nor in its mysterious twin trailing behind. It was happening on Mars itself. The first clue came from the Mars Reconnaissance Orbiter. On October 13th, its high-rise camera detected a faint but rhythmic optical flash over Utopia Planitia. At first it appeared as random pixel noise, brief glints in the infrared spectrum, barely distinguishable from background static. But when analysts stacked frames over time, a pattern emerged. The flashes repeated every 7 minutes and 12 seconds, the same interval that had defined 3I Atlas since its discovery. At ESA's control center in Darmstadt, the data was verified and re-verified. Every pulse from the comet, every energy flare, every magnetic oscillation was being answered by a corresponding light reflection from the Martian surface. The delay matched the exact light travel time between the comet's twin and Mars, 40 seconds. It wasn't a reflection in the traditional sense. The timing was too consistent, too perfectly offset. Natural reflections scatter, diffuse, and fade. This one responded with precision, as if it were listening and choosing when to reply. When scientists adjusted the image brightness, they found the pulses weren't coming from a single point. They originated from multiple locations across Utopia Planitia. Small, circular regions that brightened in perfect unison. The pattern formed a geometric lattice. 6 nodes arranged in a spiral formation, radiating outward from a central depression known as Site Theta, a shallow basin long thought to be an ancient lakebed. In archived infrared images from years prior, the region had appeared inert, cold rock, dust, nothing remarkable. Now it glowed faintly in the same spectral band as 3I Atlas's own emissions. It was as if Mars had turned into a mirror not of light, but of behavior. Theorists scrambled for explanations. Could the surface have been coated by metallic particles from previous meteorite strikes? Could frozen salts or buried ice layers be refracting sunlight at perfect intervals? None of it explained the synchronization, or why the flashes maintained the comet's internal rhythm. At NASA's Goddard Space Flight Center, Dr. Selena Yates proposed something radical. Using electromagnetic field models, her team discovered that the magnetic resonance from 3I Atlas and its twin intersected Mars at precisely the coordinates of site theta. In other words, the pulses weren't merely reaching the planet they were focusing there. Utopia Planitia, long suspected to contain subsurface ice, now seemed to behave like a resonant plate, an enormous receiver responding to external excitation. When simulated, the field lines formed a mirrored spiral matching the same Fibonacci ratio embedded in 3I Atlas's tail. For the first time, scientists saw evidence of a complete feedback loop. The comet transmitted energy, the twin modulated it, and Mars reflected it back, amplifying rather than absorbing it. The planet had become part of the signal. Then, on October 15th, the trace gas orbiter detected something even stranger. The reflected pulses contained faint emission lines at 21 centimeters, the hydrogen line used by radio astronomers to map the universe. But these weren't natural emissions. The frequency was modulated, oscillating between 1,420.4 and 1,420.42 MHz, a deliberate shift too precise to be geological. Someone or something was using Mars to speak back. When converted to audio, the modulation produced a tone that rose and fell at the same tempo as the comet's earlier heartbeat. The resemblance was uncanny. ESA's plasma lab recreated the reflection pattern in a controlled simulation, feeding the original waveform through an artificial magnetic lattice. The experiment produced the same mirrored signal, but only when the system's geometry was aligned at a 23.5 degrees tilt, the exact angle identified in the previous chapter's ancient alignment. The scientists stared at the result in silence. Geometry, frequency, heat, magnetism, all now aligned through one equation. Utopia Planitia wasn't just reflecting, it was resonating. By the evening of October 18th, the returning pulses began to change form. The spacing between them shortened slightly less than 1/10 of a second, but measurable. It was as though Mars were learning the timing, adjusting its response to match the rhythm more efficiently. In effect, the mirror was calibrating itself. That night, Mars's faint glow intensified. The reflected light, once dim and red, now shimmered faintly blue, the same spectral hue observed in the negative radiation surrounding the twin. For the first time, both ends of the system emitted identical color profiles. Across the scientific world, a single conclusion began to solidify. The planet wasn't passively mirroring the comet, it was entangled with it, physically and magnetically, part of a single distributed mechanism spanning space. Dr. Coury phrased it best during a late-night press rehearsal he never gave. We thought we were watching a reflection, but reflections don't synchronize. Mirrors don't hum. This is coordination. As 3I Atlas closed the final stretch toward Mars, the distinction between light and language began to blur. The mirror had awakened, and the planet was no longer just receiving signals, it was answering them.